7.3, solving equations using multiplication or division. Okay, so our key idea for 7.3 is the multiplication property of equality. And what that means in words is when you multiply each side of an equation by the same non-zero number, the two sides remain equal. So it's kind of the same situation that we just got done dealing with, only this time we're using multiplication, well, and division eventually. So here it is in words, make sure you copy that down. And then in numbers, it's going to look like this. If I had 8/4 equals 2, and I multiplied each side by 4, so 8/4 times 4, and that would also equal 2 times 4, because whatever I do on this side, I'm going to do on this side. Remember, this is our divider. So because I did that, now I can try and solve it. Remember, any whole number by itself as a fraction would be over 1. That would cross those out, and you would have 8/1, which would be 8, equals 2 times 4 is 8. Our next key idea is our multiplicative inverse property. So this is a little bit different. It means the product of a non-zero number, n, and its reciprocal, 1/n, is 1. So this seems to be a little confusing, but it's really not. So if we know that the product means multiplication of a non-zero, so it can't be 0, obviously, number n and its reciprocal, we have to remember what a reciprocal is. So if we have 1, its reciprocal equals 1/n. So like if we had just had any variable like that. So what this property is telling us is that if we had 1/5, or well, let me start that over. Sorry. If I had 5, and I were to multiply it by its reciprocal, the reciprocal of 5 is 1/5. So then if I were to actually do out that multiplication, it would look like this. We know that any whole number as a fraction would be over itself. Well, let's do our cross simplifying. We can get rid of our 1's because 1 divided by 1. And we can get rid of our 5's, and those going down to a 1. So basically we have 1 times our 1 is 1, and 1 times our 1 is 1, and it equals 1. So basically, the product of a number n and its reciprocal, 1/n, is always going to be 1. It doesn't matter what n actually equals. That'll come into play a little bit more as you do some of the problems. This is something important to remember, that inverse operations undo each other. So multiplication and division are inverse operations. Just like addition and subtraction were inverse operations because they could undo each other. We could say a positive 4 minus 4, well, it undoes it. We get a 0 out of it. We could do that to the other side of the equation. So that will be our same situation as we do these type of problems. So let's move right into example 1. Example 1 is solving equations using multiplication. So if you're given a problem like this, the directions would be just to solve it. So what you would do is you would start off with the w/4. You have to figure out how am I going to get w by itself, just like we did before. Remember, our equation splits right down the middle this way, so whatever we do to the left side of that equation, we have to do to the right side of the equation. Okay, so we're going to start off with, I'm just going to rewrite it over here. You don't have to if you already have it written somewhere. So w/4, if we multiply it by 4, what that's going to do is it's going to make it 4/1. And as you can see here, that would get rid of our, we could cross factor those out by saying, well, 4 divided by 4 is 1, and 4 divided by 4 is 1. They can go into each other. We can cross factor them. But remember, we have to do the same thing over here. So we had a 12 to begin with. Now we also have to multiply it by the 4. Because whatever we did over on that side, we have to do on the right side as well. So now what we're left with is, let me get my pointer here. W times 1, which gives me W. And then I have 1 times 1, which would just look like this, equals 12 times 4, which we should all be able to do and say is 48. But what we have here is W over 1. One thing you have to understand is that it doesn't matter what W equals. If it's over 1, it's still going to be W. Do you actually have to do this step right here? No, you don't have to put it over 1. If you find out that your answer is W equals 48, then you're in good shape. Now usually I would have you do your check over here. I just don't have a lot of room, so I'm just going to do it right over here. But you do need to do your check to begin with. So we have our W, which is what our unknown was, and it's over 1, or I'm sorry, over 4, and it equals 12. So we rewrite out what we have. Then we fill in what we know we have for what W equals. It happens to be 48. It's over 4. It equals 12. All we have to say is, how many times can 4 go into 48? Well, we should know that 4 times 12 equals 48. So we could be able to say, well, this does equal 12, and this does equal 12, so it does check out. So this one's a little bit different. This is where we're going to use our multiplicative inverse property, because we can't just, we've got a 2/7 times x. And so we have our fraction here, and we can't really do anything with that fraction or get x alone until we can get rid of what that fraction is. So what we're going to do is we're going to do the multiplicative inverse property, where the product of a non-zero number n and its reciprocal 1 over n is 1. So an example would have been, take what you have, so we have our 2/7, and we're going to multiply it by its reciprocal, because guess what that does? It equals 1. So now we're left with 1, and I'm going to put that right here, but don't forget about our x. We've got to put that down. All we did was we got rid of the 2/7. Okay, so we're down to 1x. What's really nice is we don't have to put that 1 there. We can just leave it as x, and it equals 6, but we have to multiply it by the same thing we did on this side of the equation. Okay? So basically, I'm going to rewrite this over here and kind of re-explain it, because it can be a little hard to understand. So what I did here was I took the reciprocal of 2/7, which is 7 over 2, and I multiplied it by 2/7. Okay, and I still have my x there. And over on this side, I have to multiply it by 7. Oops, I should do that one in green, sorry. I should do the same thing over here, so that I'm proving that I'm multiplying them both on the same side. So what's happening here is I can say 7, I could do it like this. I could do 7 times 2 is 14, 2 times 7 is 14. Well, 14 over 14 equals 1, because 14 can go into 14 equally. So that's why we don't have to put that 1 down here. Basically, they get rid of each other. They leave us with x all by itself. Now I have 6 times 7 halves, or 6 times 7 over 2. And if you had to do a little side math, you can always make 6 a fraction by putting it over 1 times 7 halves. Can I cross factor anywhere? 2 divided by 2 is 1. 6 divided by 2 is 3. So now I'm left with 3 times 7 is 21 over 1. So I'm left with just 21, because I don't have to have it over 1. So that means x equals 21. Because don't forget that this right here was just me solving this. So I'm left with x equals 21. Now I'm going to go to another page here, and I'm going to do a check just to make sure I'm right. So remember, always with your check, that you write your original equation. So I have 2/7, and I would fill in what my x would be, and my x we said was equal to 21, and that should equal 6. So now we're going to do some side math and do 2/7 times 21 over 1. Okay. And we can do some cross factoring. 7 divided by 7 is 1. 21 divided by 7 is 3. 2 times 3 equals 6, and it's over 1. So we know that my answer over here should be 6. Does 6 equal 6? Yes. So it does check out. X does equal 21. Now, I've said before that sometimes it's hard to just mentally find out what these are, and that's why it's important to use a check in the end, okay? It's really important. Okay, I'm going to stop here, and we will do some practice with this type of problem in class.